Today we are going to continue in our matrix, multiplication of matrix. Under our multiplication, we are going to take first the scalar multiplication. Now, scalar multiplication of a matrix is when a single number is used to multiply a matrix. It's referred to as scalar multiplication, and that single number will multiply all the individual elements inside the matrix. Let's look at an example. If we are given a matrix A equal to -2, 1, 5, 3. Let's say we are given a matrix like this, and we are now asked to do what? To find 2A. You are asked to find 2A. It means you are multiplying matrix A by 2. So what do we have? Let's look at the solution. Solution. If we are to multiply A by 2, so our 2A giving us what? 2, open bracket, what? -2, 1, 5, and 3. What do we do in our scalar multiplication? Is for us to use this value 2 to multiply every number, every element inside. So we now have 2 times -2 will give us what? -4. 2 times 1 will give us what? 2. 2 times 5 will give us what? 10. And 2 times 3 will give us what? 6. So this becomes our answer. Now let's take another example. Find, if you are asked to find -3A. If you are asked to find -3A, so we are using -3A, means -3 will multiply every value inside our matrix A. We have -2, 1, 5, 3, open bracket. So what are we going to get? -3 times -2. We are going to have what? Our -3A will now be what? 6. -3 times 1, we have what? -3. -3 times 5 will give us what? -15. And -3 times -3 times 3 will give us what? -9. So this is our answer. We are going to look at matrices multiplication. Multiplication of one matrix with another matrix. Now, when we want to multiply 2 matrices together, we can only do that to multiply 2 matrices together if the number of columns in the first matrix is equal to the number of rows in the second matrix. Example, e.g., given matrix A, given matrices, or let me say given matrices, A is equal to -2, 1, 3, 1, 0, 4. Then given B, 3, 1, 2, -1, 4, 3, find, you have to find what? A times B. This dot here is used to represent multiplication when we are carrying out matrices. We are saying multiply matrix A times matrix B. Now let's see, can we multiply A and B? First, you must try to identify if they are compatible for multiplication. And what is that compatibility? The matrix A, first matrix. What is the column? The number of column in the first matrix is how many? 1, 2, 3. The column is 3. We see that the number of column in the first matrix must be equal to the number of row in the second matrix. Our order here is given as what? 2 by 3. This is the order here. So the number of column here is 3. Now let's look at the number of row in the second one. 1, 2, 3. We have 3 row by what? 2 column. We are saying that if the number of column in the first matrix is equal to the number of row in the second matrix, then we can multiply them. We are going to multiply matrix A times matrix B. Now, let's look at the solution. We must pay attention carefully to this. Our A times B, we have minus 2, 1, 3, 1, 0, 4 times our B is 3, 2, 4, 1 minus 1, 3. This will now be equal to. Now, how do we carry out the multiplication of matrices? I want us to pay attention carefully. We are going to multiply using the first row to multiply the first column. We use the first row to multiply the first column. Subsequently, we are going to add them. Let's see how we are doing that. We are going to take minus 2 times 3. This is minus 2 times 3 plus, we take this 1 times 2, 1 times 2 plus, and we take 3 times 4, 3 times 4. This is how we carry out this multiplication gradually. We are going to do the same thing with this first row and this second column. The first row and the second column. Minus 2 times 1. Minus 2 times 1. Plus 1 times minus 1. 1 times minus 1. Plus 3 times 3. 3 times 3. When we are through with that, we'll go to the next row. We do the same thing with the next row here, using this second row to multiply the first column. Let's go. 1 times 3. 1 times 3 plus 0 times 2. 0 times 2 plus 4 times 4. 4 times 4. Then we go to the next one. We use the same, this row to multiply this column. 1 times 1. 1 times 1 plus 0 times minus 1. 0 times minus 1 plus 4 times 3. 4 times 3. Now all this in what? Brackets. So now let's multiply Minus 2 times 3 will give us what? Minus 6. Plus 1 times 2 gives us 2. Plus 3 times 4 gives us what? 12. We go to the next. Minus 2 times 1 gives us minus 2. 1 times minus 1 gives us minus 1. And 3 times 3 gives us what? 9. Now let's come down. 1 times 3 gives us what? 3. Plus 0 times 2 gives us what? 0. Plus 4 times 4 gives us what? 16. 1 times 1 gives us what? 1. Plus 0 times 1 gives us what? 0. Plus 4 times 3 gives us what? 12. This is where student normally makes mistakes. That's why I'm taking it gradually. You must follow the process. We are multiplying the row to the column. The row to the column, and we take this minus 2 times this plus 1 times this plus 3 times 4. Final answer is what? Minus 6 plus 2. Minus 6 plus 2 is equal to what? Minus 4. Minus 6 plus 2 equal to minus 4. And minus 4 plus 12 is equal to 8. So we now write here 8. Minus 2 minus 1 gives us what? Minus 3. Then minus 3 plus 9 gives us what? 6. And we have what? 6. Go to the next. 3 plus 0 is 3. Then 3 plus 16 gives us what? 19. Now write our 19 here. And we have 1 plus 0, 1. And 1 plus 12, 13. So this gives us what? Our answer. So our A times B is equal to that. Let's look at another example. Question 2. We are going to give in the matrices. Let's say D is equal to 1 minus 3, 2, 4, minus 1, minus 2. And let's say we have E, matrix E, and we have 3, 5, we have 4, minus 1. Now let's look at that. And you are told to find D times what? E. Find D times E. First, let's look at if they are compatible for multiplication. If they are compatible for multiplication. For us to know if they are compatible for multiplication, the first matrix, the column, must be equal to the row of the second one. So what's the first matrix column? 1, 2. The column here is 2. And what is the row in the second one? 1, 2. So since the column in the first is equal to the row in the second matrix, then they are compatible for multiplication. So let's carry out the multiplication now. Solution. We are going to carry out that D times E. D times E. And what do we have? 1 minus 3, 2, 4 minus 1 minus 2. And we have 3, 5, 4 minus 1. So this is what we are. So now let's evaluate. Let's evaluate. We are taking our row to multiply the column. We take our row in the first to multiply the column in the second, and we add them subsequently. So now let's go. 1 times 3. I'm going to be writing the answer finally there. 1 times 3 is equal to what? 3. 1 times 3 is equal to 3. Plus minus 3 times 4 will give us what? Minus 12. So we are through with that. We take the next one. 1 times 5 gives us what? 5. Plus minus 3 times minus 1 will give us what? 3. Will give us 3. So we are through with that. We go to the next row here. 2 times 3 will give us what? 6. Plus 4 times 4 will give us what? 16. We go to the next column. 2 times 5 will give us what? 10. Then 4 times minus 1 gives us what? Minus 4. We go to the next row. Minus 1 times 3 will give us what? Minus 3. Plus minus 2 times 4 will give us what? Minus 8. We go to the next. Minus 1 times 5 will give us minus 5. Plus minus 2 times minus 1 give us what? Plus 2. Let's add up. What do we have? 3 minus 12. And that will give us what? Minus 9. 5 plus 3. That will give us what? 8. 6 plus 16. That will give us what? 22. 10 minus 4. 10 minus 4. That will give us what? 6. Minus 3 minus 8. That will give us what? Minus 11. And minus 5 plus 2. That will give us minus 3. So this becomes what? D times E. The last thing we are going to consider today is transposition of a matrix. To find the transpose of a matrix is just to change the row to become the column. Changing the rows to become what? The columns. That is all about what? Transposing a matrix. Transpose of matrix A can be written as A raised to power T. This is the symbol we use for transpose, raised to the power of T. Now, let's look at an example. Say, find the transpose of matrix B equal to 3 minus 2, 5, 7, 0, 8, minus 4, 1, minus 9. So they want us to find the transpose of that matrix. The solution becomes what? Solution B transpose raised to power, that is B to the power of T, is the symbol to show the transpose of B. So what are we doing in transpose of matrix? Is to turn the rows to become your column. So we now have 3 minus 2, 5. The next row becomes 7, 0, 8. And we have what? -4, 1, and -9. So this is the transpose of matrix B. In our next class, we'll be looking at what? The determinants of a matrix.